All right, we're gonna do a cold start on this thing, the 351 Windsor, which it's not really cold at all. It's like probably 40 degrees, and this is pumped gas, so. It's gonna be an easy one. Degrees. I was wrong. All right. Let's try to drive it. It might not like this. Welcome back. Some of this may be familiar to some of you. Some of it may not. But if this is your first time looking at this project, I'm going to give you some tips to not make the same mistakes, or not mistakes, but just save you time if you're trying to change valve springs or stem seals with the engine in the car. So again, this is like the fourth time I've had to do this, so not all of it is unfamiliar. The first time I found I had a smoking problem, I found that the valve stem seals were pushed up off the guides, and I just took it apart and found that it is pushed up again. So anyways, this time it's getting a lot easier than in the past. I don't know if it's because I've just done it so many times, but one of the things is I'm using this LS style tool. I'm going to show you that in a second. But first I want to show you the valve stem seal job. So if you remember the last video, or the first video, I took apart the engine and found that the valve stem seals on all the cylinders were pushed off the guides and they were just riding along on the valve. I thought that was the smoking problem, but turned out I replaced the heads and still had the problem. So the second round, I replaced the valve stem seals with new ones, and the third round, I actually RTV'd them on, like you see here. So far, I have done 5 of the 8 cylinders, and this is what I'm doing. I've got these springs because, like I told you before, I have been having problems getting it to rev, and the rev limiter seems to be somewhere in the upper 5s. I can't even get 6,000 out of it, so I tried shimming the springs last time with washers. I shimmed them 95 thousandths for an installed height of about 1.75 inches, and that still didn't give it much. I mean, I'm still hitting an RPM of about 5,800 before I start to see signs of valve float. So I'm hoping to fix that with these. These are some Lunati springs, supposedly. I don't know if this is actually the right box, but they have 1.5 inch outside diameter, 1.115 bind height, and I think 0.8 is the inside diameter. But also what's nice about these is that the ones that he marked with black are stronger. So these are the dual springs that came in those aluminum heads, and these are the ones I'm installing. Now, like I said before, I've had issues with the valve stem seals coming off of the guides, and I have a new plan for that. I'm starting simple with what I have laying around. So what I've done is ordered a few different types of seals here. These are the ones that are originally on the heads that I bought. They're a VS305V. And these ones, I just don't know. They don't like the exhaust side very much. So here's what I've done. This lower ring, if you look at this, this is normally on the top. So for the exhaust seals, on all the passenger side, I did it in this way, where I doubled up the rings on the bottom and took off the top. Now that does 2 things. One, it will help this valve stem seal clamp onto that guide. See that? Because once these are installed, there's a gap there. The other thing that it does is it gives this top area something to vent. Now, I think I actually on a few of these valves, I'm going to try this, where I've added just a ring on the bottom, and I'm going to put these on the intake and see if they'll stay down. Because with the RTV, I had all the intake valve stem seals stay down, and the exhaust ones didn't. But if this doesn't work, I do have a backup plan. So like I said, I ordered a few different types of seals. They're here. You know, some of them have like a double ring on the bottom. Some of them have, this is actually an interesting one because it's more like this seal, except it has a taller band there. So if you look at that band, it's actually bigger. So I don't know. I'm going to try this out, and if this works, I think that that'll be great. probably try to put the top ring back on to get better sealing right here on all of them. If it doesn't, I've got this guy. This is apparently for a Nissan forklift, and it's a top hat style seal. Now the reason I'm not putting them on right now is because A, I don't have enough of them, and B, those springs don't fit inside of this. And I don't know if I need these on all the cylinders. I think on all the valves. I think I just need it on the exhaust side. So there's a couple other styles I ordered. These are like a metal clad. I tried to install these with a special tool made out of aluminum, and I was damaging them. So I don't think that's the way. This compressor, this is the end of this. You will not see this again. The last time that I used it, it folded up even further, and then these threads got stripped. You can see that they're cross-threaded between this drive and this. So this thing's headed for the scrap bin. I do not recommend using one of those if you're looking to do this job on a double valve spring setup. Like I said, it might work better for a single, but I barely was able to get this to work, and that was only because I welded on reinforcements. So stay away from these. So what I've got right now is these bolts right here that go into the rocker shaft mount. These are just hand tight, and same with this. It's about as tight as I can get it by hand. So next up, I'm going to pressurize the cylinder. Truck moves a little when that happens. I have the e-brake on and the truck's in gear, so you can hear a little bit of air. It's coming past the rings. That's normal. So what I'm going to do now is I'm going to tighten up this center stud that's going to compress both of the springs, and you'll hear a valve open once I tighten it down enough. Okay, so it lost pressure. So that's an intake valve. So I'm going to back it off, and this is the key. This is the mistakes I kept making. Okay, back it off till it restores the pressure to the cylinder. Now, I almost lost a keeper because I was not doing this in the right order. This is how you do it. So I've got a 13mm socket, and the intake valve is the one that's kind of hung up. So I've got just enough pressure there to hold it. I'm going to do like 30 light taps. There it went. So you hear it kind of click, and now the air's not coming out of the intake valve anymore. So we're going to do that for the exhaust side. Boom, that didn't take as long. Now, I always find that the intake valves are the ones that fight more, and the exhaust valves, on the other hand, those are a little easier to work with. So make sure you got your glasses on for this. By the way, those keepers can go flying. So yeah, you want to just put a little bit of pressure on it and then give it light taps. If you hit it too hard, you'll have a keeper fly out, and you better hope that that keeper doesn't end up down in these depths here. You know, it could go down into one of those passages. If you don't have your intake manifold blocked off, it could go in there, it could fall somewhere, and you just don't want to deal with that. So now that I have popped loose the keepers, that's the secret, and the instructions aren't going to tell you what I just showed you. So this should now allow me to tighten it up without opening a valve. So now we're going to pop the keepers off. I'm going to show you what's underneath these springs. So they're kind of stuck, but we'll get them. So now that this is off, you're about to see the problem with the stem seals and what I did to modify this tool. So here we are. That is the weld. The problem is it's too wide this way to fit in between the coil springs because those coil springs are too close together. So I just grinded the sides off until it was flush with the threads, and then I fused together this bolt with this carrier. I used the stock Ford bolts, and this piece worked perfect. So don't use power tools on these. Finger tighten these two so that it can kind of move around if it needs to, and you'll be set. So I'll get you a better view here on this. There we go. This is the exhaust side, and lucky winner, the seal is popped off. Not surprising. There's the intake side, and it seals fine. So again, the problem seems to come more from the exhaust than the intake on this. I've seen that over and over. I think every single seal now is popped up, so hopefully this helps with the oil consumption. Even with running it like this with all these exhaust seals popped off, I'm still only burning about a quart every 1,500 miles, so it's not terrible. It really only smokes at idle. But with these seal modifications, hopefully we can keep them down. So you can see there, that silicone from last time just did not bond at all. It failed. It was worth a try. It did last for a while. And I gotta say, I pressurized this exhaust quite a bit. So if you were naturally aspirated, you may not have this problem at all. And even with the positive pressure from the intake valve's not really, I don't know if it's because the guide doesn't get as hot, but it's not pushing this seal off. So it seems like the sealant, though, either way, did not fix it. I got all the valve springs in. Here's these ones that came out. They are a dual valve spring that came with those blueprint heads. They're supposed to, I'll put the specs up, but they were not enough. So I don't know if it's because of boost or they're just weak to begin with. So this end spark plug wire broke off and I'm replacing it with this tight 90 here. What happens with these, I've had this happen several times, is the second piece that goes in here breaks off, so you're left with just the wire. Very easy to install, just use these specialty crimpers, and I like to use another pair of cutters. These are in here, do awesome to strip those wires back, but I'll show you how that's done real quick. So all I'm going to do is take this wire, this is just an 8mm standard wire, nothing special, fold it back and crimp this new connector on. So show you how that's done. Alright, one more of these and then we're going to do the first start. So this is the spark plug wire for cylinder number 8, and just like the other side, I'm going to slap this Taylor 8mm 90° on there and give it a little crimp to get it started, and then crimp it twice. So the other thing about crimping this is it doesn't just attach it, but if you don't crimp it twice, then parts of this thing will stick out of here and you won't be able to slide it into this rubber boot as easily. So I don't know how these things hold up over long term, but you know, if you break off a spark plug wire or melt one, it definitely gets you back up and going without having to replace the whole set. And I wish I would have started doing this earlier on, because I can't tell you how many sets of wires I've gone through because one or two of the long ones had broken off, and those factory ends are just not that good to begin with. I don't know if it's the heat or just the shape of them or the heads that I have, but you know, I think that this will probably outlast that because it doesn't have that weak point in the middle where it breaks. So that definitely has a lot going for it, and like I said, we'll see how they hold up long term. But I'm gonna go ahead and attach the spark plug and we're gonna start her up. Like I said, to recap, this is about the 4th time I've pulled the valve springs off of these heads, and this time we went with some pretty aggressive springs at the same installed height as last time, so I kept those washers underneath. So yeah, we'll see how this round of maintenance holds up. I'm hoping to get a few more 100 RPM out of there. I have not hit 6,000 with boost without floating valves is what I think is happening. So hopefully this helps out, and we'll see if we can get a little more RPM out of it next time.